Well, hello everyone. This is an unusual stream because I'm trying to do something in VR here with Landon, and it might even work. So while
Wow.
while I try to get that actually going, we're probably not going to be able to see Landon. So that's unfortunate. But
I'm virtually there.
yes, you are. So
Good morning, good afternoon, good evening from your friendly secular astronomer, and depending on your time zone latitude. And we even have someone from Vancouver Island. That's a cool spot.
nice.
Up there in friendly Canada.
Well, welcome from Canada. I like Vancouver Island. So hopefully, while we do this stream, I'm going to go fly in a spaceship from Abraham Lincoln Station in orbit of Earth to Betelgeuse, with Landon hopefully on screen for most of it, as well as chat on screen for most of it. But, you know,
We shall see what we shall see.
yes,
And,
exactly.
This, of course, is neither a refutation nor an endorsement of general relativity. It is for fun.
Yes, this is in fact very inaccurate in terms of science. So we're just gonna go ahead and accept that, or it's for entertainment purposes.
And that's one of the nice things about science fiction is you get to say, well, what if, right? And so this would be a what if you could go Betelgeuse. And of course, the thing that would be nice to have more detailed view of Betelgeuse is that it is a very interesting supermassive star, or as Red Eye prefers to call it, a tubby star. And Betelgeuse was in the news recently because it became noticeably dim for a while, and you could even go up to look at Orion and see where it used to be, what stars it used to be, was same brightness of, and it faded quite a bit, and now it's back. And so seeing the Orion around Betelgeuse and understanding its turbulence in its surface would give us tremendous information about these super massive stars. And Betelgeuse is one of those fairly massive stars. It's a fairly young star, and it will only be around for a short period of time. It's probably in the age of around approaching 8 million years, and it probably has maybe 100 million years left before its core runs out of exothermic stuff to fuse and becomes endothermic and undergoes a stellar collapse and supernovae and likely formation of a black hole, which would be okay for us. Earth would be just fine, but it would be very instructive. Unfortunately, it probably has 100,000 years left in its life. So, that being said, I also have to say that, speaking of friendly Canadians, I did convince another Canadian to in the same game travel from Sol to Betelgeuse, and they were relatively new to this game. I haven't played it, but I've seen other people play it, and they're relatively new in this game. And they got into a spot. They didn't really understand how to do the navigation. They got to a spot where they ran out of fuel and had to have the fuel rats come in and rescue them.
Ah, yes, I've not had that. Oh, and thank you for the happy birthday. Got a happy birthday.
Is your birthday today?
No, it's my birthday a week from tomorrow, but...
Okay. I was going to say 66 million years and... Much older. So I thought you were a piker when the Chicxulub Impactor came around.
Oh, no, I was already older than you would see Tyrannosaurus Rexes.
Okay. Well, now I've been corrected.
It's kind of a weird thing to think about in terms of like how long Earth's been around, and we think of the time of the dinosaurs as being a somewhat coherent period of the same kind of duration as like the time mammals have been around.
Mm-hmm.
But no, mammals have been around for, well, the age of mammals has been much shorter. than the age of the dinosaurs, if you will.
Yes, I mean the problem, of course, is that the really is sort of the underpinnings of the biosphere that the heavyweights depended upon got knocked out from under them through a series of events. One of them most likely would be an asteroid of significant size that was contained dense metals in things like iridium and platinum struck the Earth. They're also at the same time and possibly caused by a huge volcanic system eruptions that occurred over in the Indian subcontinent and other sorts of things. So it had Earth had a really bad day for
For a few million
a
years?
series of a number of years, causing causing both plants and plankton and critters like that in the sea to die off in a high proportion, which killed off the things that ate it and on up the food chain. So unfortunately for dinosaurs, the things collapsed. Fortunately for mammals, they got to scurry around and not completely die off, and are now currently running the ship, as we say.
Well, unless you count all the bacteria and insects.
That's true. I mean, they did, and there were certainly critters that survived. In North America, the redwoods, the great Sequoia sempervirens, Sequoia gigantea redwoods, survived the impact site. The alligators, were another thing that survived, and cockroaches. So several things. It wasn't complete extermination, but Earth did have a bad day.
Yes,
For a number of years.
very bad. No good day for. Actually, there's some thought that the weather effects and the climate effects might have taken somewhere around a few thousand years to really kind of calm down from being in sort of ridiculous horribleness,
Yeah.
which is one of those reasons why nearly everything on land and a lot of the stuff in the water goes extinct, because there's only so long you can go without having any, food production.
Certainly, we know from the impactor, we know its composition and its size, and we know the angle that it came in, and we know that the material that it formed. I think I believe the crater was something like 84 kilometers across that it gouged out, and the ejecta from that crater, because it came in at a shallow angle, had sort of a forward momentum that went out of the atmosphere and came back down into the atmosphere over North America. And the result of that material, of many cubic kilometers of material raining down in as fireballs, is that the atmosphere, the ground got hotter and hotter and hotter as its income falling material increased temperatures. And at some point, the temperature in the ground reached ignition temperature of plant material. The North America was covered by virgin redwood forests, and the nearly entire forest of North America caught on fire at effectively the same time. It's not a fire, a bad forest fire that moved through. The most of North America turned into flame at the time. There was some along the very far western edge of North America that survived, that were not, that it didn't reach ignition temperature, but most of the entire thing, you had a continent-wide flame that turned on. Of course, the things that were in the middle of North America were toast, but the other thing is that much fire put in the atmosphere really spiked up the temperature, and it then dumped an enormous amount of soot into the atmosphere and darkened the atmosphere as such that you would not have been able to spot the sun in the sky for several years. That much smoke and ash put in there. That stopped photosynthesis, and it caused all kinds of problems, amongst other things. And there are many things that happen. And this wasn't the worst of the extinction events. This was on extinction events, this is not at the 9 or 10 level. This is like at the 7 or 8 level for
Right.
things. But I could say in my connection with it, I know that of course you certainly lost a number of your relatives.
Oh, they'd all been dead by then.
And of course, the other thing is that but I've had the privilege of finding a nodule about the size of sugar cube down in Antarctica, about at 80 degrees south latitude, and it was a piece of it was a meteorite that had high concentrations of iridium and platinum whose element mix matches the boundary layer where the dust from that asteroid is found. That also gave us one of the key evidences that the Impactor is not a comet, but actually was a metallic asteroid, a fairly dense metallic asteroid.
So we do have a couple of questions. One is whether or not I allow guests in. So that is something that I prefer to have as a prearranged sort of deal. So if Landon is given a heads up that we might have another guest, and I ask him if that's okay, I don't like to spring guests on him. So probably won't do that.
I mean, one thing that you could do if it's your show, is that we could go through some of our news stuff and then later on can simply open it up to other people, but that's your choice.
We might. We'll see how long news and everything goes through. The other quick question or comment is, yes, I am aware that several birds survived. Yes. When I said my relatives, I more meant parents, siblings. They'd all died out long before, yes.
Kinfolk.
Yes. Birds aren't any descendants of any of my family.
Yeah.
But the other thing is, so basically every time I try to launch the game in which I was going to fly to Betelgeuse, my headset crashes, and so we're not gonna fly, unfortunately. That also might mean that exactly what I do on my birthday for the gaming section might change, because if I can't get it to stream, there's no point in me trying to stream it. So I'm going to try a few times to stream it to Top Hats Off to see what I can do. Feel free not to show up, because they'll just be crappy test streams, but there you go. Sorry about that, guys. But anyway, so what do you want to cover first in terms of news, Landon?
Well, what we were talking about the nearby black hole that from the beginning, so maybe that's something we can talk about, the recent discovery.
Yes, as far as I understand, it's the closest known black hole to our solar system.
Yes, and it's a distance is now set at around approximately 1,120 light years away.
Okay.
And it is in it's a member of a star system that has the it's a star system with a lovely name of HR 6819. HR 6819. HR is a designation for a star catalog, bright star catalog, and by bright meaning it's brighter than the really faint stars that telescopes can see. But it contains HR catalog contains stars of 6.5 magnitude or brighter. It focuses on that spot. There are other extensions of the catalog that go fainter. And so the bright star catalog, if you will, the HR stuff are things you can see. And so this particular star group appears as a very faint star in the sky in the southern hemisphere in a constellation known as Telescopium. And you have to be way south, allegedly. I mean, maybe, for example, in Australia, allegedly. And at that point, you can see Telescopium. And in that constellation area, there's a fairly faint star that if you're in good sky conditions, you can see. That star is actually 3 objects. And it turns out one of those objects is a black hole. Now, you can't see the black hole, but you can see the star group that the black hole is a member of.
So is it detected via examining things like the orbits of its companion stars and noticing that there's a third source of mass that's causing disruptions that we're not seeing?
And yes, and in fact, this particular thing was detected again by the orbits and determining its mass, and then of course the other thing is that it was inferred to be a non-accreting stellar mass black hole. So it means it's not actively sucking in lots of material. It it obviously is getting some material in nearby space, but its environment surrounding is relatively matter free. So it's one of these fairly quiet black holes. It has a mass of approximately 4 times the mass of a sun. So we call it a stellar mass black hole for that region. But it's part of a triple star system that consists of 2 B-type giant stars and a unseen third companion, which, based upon material and mass, we've been able to determine is actually a black hole. It's, at least as of this year, it's the closest known black hole, even though it's not an actively gobbling black hole.
Hey, it's still there. It still exists.
Yes.
Black hole.
And again, not all black holes are actively, grabbing stuff there. There's lots of black holes that are relatively benign. In part because if the black hole were non-accelerating or non-rotating, let's say for example, and the event horizon, the point of no return, you call 1, then if you were orbiting at 3 or farther from it, you'd be in a fairly stable orbit. You could orbit forever, and you wouldn't. Yeah. And as long as someone didn't knock you into the unstable period spot between 3 and 1, which between 3 and 1, your orbit started to decay, and then when you went beyond 1, you're inside the event horizon, and for all purposes, you've gone away from our experience.
Yeah, well, I think that's one of the things that media portrayals about black holes tend to get wrong. They seem to look at them as like, oh, they're just vacuum cleaners. But the thing is, like, if, say, the sun became just all that mass was compressed instantaneously to be a black hole, Earth would continue orbiting the whole solar system would continue orbiting just fine. It would get super cold.
Yeah.
But the orbits would be undisturbed.
Exactly. And so there's nothing magical. The only reason why we call it a black hole is because the density of material is high enough, the gravitational field is strong enough that light can't escape. That's what we say is a black hole. And you're right. There's nothing magical about that. So this was likely a massive star, like produce something like Betelgeuse, that underwent stellar collapse, and its black hole got, in practice, perhaps this was a massive star. These 3 stars had a Betelgeuse like companion with these 2 stars orbiting it. The massive star collapsed, it became a black hole, and the other 2 stars continue to orbit because they're outside of the unstable zone, and so they're continuing to orbit just fine. Now, if gas clouds come along, for example, as they're orbiting around the Milky Way galaxy, and there's a bunch of other stuff kind of counter-rotating inside it and so forth, it'll flare up. When the Andromeda galaxy finally merges with the Milky Way, there's a reasonable chance that dust and gas clouds from the Andromeda galaxy will find their way in the vicinity of this black hole, and it'll start to gobble up some stuff and become active for a period of time. But again, material that comes into that unstable zone. Now, if it's rotating, that zone of stable of 3 gets closer and closer, such that if the black hole were theoretically orbiting its orbital speed on its equator was close to the speed of light, then the stable part you could get down to almost next to the event horizon.
Right.
So 3 is non-rotating, 1 is rotating nearly the speed of light, and that's kind of the rules for.
Monk Mayfair points out, if a black hole weren't rotating, the birth star wouldn't have been rotating. So yes, the non-rotating black hole is largely a hypothetical construct in physics that's useful for examining ideal cases.
Yes.
It's unlikely that any of them actually exist, although if I do remember correctly, they do tend to lose rotational energy on net over time as a result of things like gravitational interactions and whatnot.
And it also depends on how the thing collapses. One of the intriguing stellar collapses that we actually got to witness was in the Southern Hemisphere again. Southern Hemisphere gets some of the best events, I must say, comets and so forth, allegedly. And in 1987A, there was a supernova in the Large Magellanic Cloud. That's one of our satellite galaxies.
Mhm.
And that particular object was what we call a blue straggler. It was a massive star that underwent enormous eruptions and blew off its outer shell. And it was sort of like having a naked core. It was mostly stellar core, a little bit of convection zone and fuzz around it. It had in its final stages outbursts and it's pushed off most of its shell. So it was a similar core. And so the core, when it ran out of enough fuel, underwent gravitational collapse. It's possible that collapse was not symmetrical but asymmetrical. That perhaps it had another companion and it was off-centered or something. The result was that it didn't collapse. We don't believe towards its center. It collapsed off to the side, and that had an effect of squirting out a bunch of material out the other direction. And so, sadly, we don't think that a black hole or even a neutron star formed from that particular one. But had it formed there, it might not have had much in the way of rotational angular momentum. I mean, it'll have some, but again, we're talking about these are idealized range between it's not rotating, it's at 3 to it's rotating to near the speed of light, and it's at 1. Where 1 is the distance out to the event horizon.
Okay. We also have a comment from Nussig20 who says that he thinks that gravity waves would cause the solar system to dissipate momentum, and so eventually orbits would no longer occur. I don't know that gravity waves on net are likely to do that, but there are other things that are likely in the extreme long term of the universe to cause the solar system to some degree go away.
So I believe he's referring to gravitational waves that are a result of one of the amazing results of predictions of Einstein's equations. And there is energy that's would be radiated, but the gravitational waves that would be being produced would be produced by the planets, not the actual center mass of the black hole itself. Now, if that mass is moving because it has momentum, if it is in orbit around another, let's say, massive object like another black hole, then the two orbiting things will introduce gravitational waves that will be a consequence of space warping, and energy will be depleted from there. But if you have a singleton system like we have here, there's probably not much in the way of gravitational waves being generated. It's true, those two giant stars in that star system, that is in HR 6819, are causing the black hole to move, but so are they. And so it's a fairly low. Their speeds are fairly terrestrial, as far as astronomical speeds go, and so and the masses are stellar masses. So their gravitational waves that would be fairly weak. Yeah. Most likely, what you'll see instead is that the other stars, depending on their size, I mean, they are B-type giant stars, so they have the possibility of collapsing and forming, let's say, a neutron star, or perhaps a black hole, depending on their mass. And those things would then kind of orbit each other. They get buffeted around a little bit because of the supernovas tend to give things a kick, but they'd settle into an orbit, and then they would just have a period of time where they get fed every once in a while, like when the Andromeda Galaxy merges. There'll be dust and gas clouds that they can feed on for a little bit. But then they go back to just being their own quiet cells, radiating very, 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 very slowly by Hawking radiation.
Yeah. Now, as and the 620, yeah. When I said forever, I basically meant that the lifespan of the orbits in the solar system would not be affected by the sun becoming instantaneously a black hole. And
yeah, and of course, one of the big things, of course, you'd have a loss of is solar radiation, and things would get very cryogenically cold, right? Well,
not Jupiter wouldn't get too cold. It currently radiates more heat than it gets from the sun,
but it still is cryogenically cold on the surface of Jupiter. Inside is a different story, but
Yeah.
But outside, it's not.
You think
It's not.
Io might
It's not.
stay volcanic since it's mostly tidal heating that's keeping that going?
Well, that's a pretty good thing. Actually, that's one of the things that as planetary science I study in actually quite detail. And Io's volcanism is largely due to the fact that it's in what's called a Laplace resonance. The three of the four heavyweight moons of Jupiter are in a weird resonance where Io goes around 4 times, Europa goes around twice, and Ganymede goes around once. That 4:2 ratio is fairly exact. It's also an interesting phase where you don't have a case where all 3 are on the same side. When you have 2 of those 3 that are at the same line from Jupiter, the third one is at a right angle.
Okay.
So it's a very exact Laplace resonance set that causes the moons, which would otherwise have a fairly circular orbit, to become elliptical. It's that moving in and out from Jupiter that causes, and you have a different gravitational field strength that causes tidal flexing. It's part of the effect of tidal flexing. And so on Io itself, a moon that's roughly the size of our moon, the rock has tides that are probably on the order of 150 meters. That's around almost 500 feet. And every 84 hours, the thing gets squished and stretched. That size that produces a lot of creates a lot of thermal power. And so the primary thing is this stretching heating. It's kind of like acting like an accordion where it goes as it every 84 hours goes in and back out towards Jupiter. I mean, a little bit. It's not exaggerated like a comet typically is, but it has a little bit of circular thing. It also has a problem that it wants to spin around. It is tightly locked with Jupiter, and so it wants to have one face always pointing Jupiter as it moves around. The problem with it being tightly locked is that if you know about how something operates in an ellipse, as it gets closer to the parent body, it goes faster. And as it moves away, it gets slower. So it goes fast, slow, fast, slow. But the spin of the axis wants to be constant. So while it's moving faster, the phase is kind of lagging. And while it's moving slower, the phase is kind of leading. And there's also twisting and turning going with that process. Finally, there is an enormous magnetic field around Jupiter, and the volcanism that's on Io is spewing out ions that escape, and those ions then accelerate around the magnetic field and slam into Jupiter, create giant auroras there. But there's a huge electric current because Io is effectively like a semiconductor moving in a magnetic field. When you have a conductor in a magnetic field, you generate current. There is several, the current that's going through Io is on the order of several tens of billions of amperes of current that's flowing between Jupiter and Io.
So the electric universe people were right all along, as long as we stick to just Jupiter and Io. It's
a secondary effect. The first effect is from the titles. The secondary effect is this heating thing. So the result is that
we could give them one win.
the result is that it radiates, has a thermal output around 93,000 gigawatts of thermal power is being radiated as a result of this thing. When we measure the thermal output, we can take infrared telescopes and look at Io. We can calculate how much heat is coming off it. Right? Infrared, we can see the heat coming off. And we find that the calculated thermal power from the current and the gravitational twisting and tugging almost exactly matches the amount of heat coming off of Io. That is, it's 93,000 gigawatts of thermal power is almost entirely due to the orbit characteristics and this current. So what does that mean? Well, it means if it wasn't orbiting in a circular orbit, if it wasn't elliptical orbit, it had a circular orbit, it would not have those tidal things, and it would go cold. And in fact, that's what's happening. Very slowly, Io is moving towards Jupiter, and Europa and Ganymede are moving away from Jupiter. That 4-2-1 Laplace resonance that's there is kind of that. It's kind of like when you have your dryer, spin dryer, and you're trying to dry your sheets, and they get bunched up on one side of the dryer, and the thing starts wobbling around and creating a racket. Well, that's sort of the racket that's going on right now with these 3 moons in Laplace resonance. And so when that thing finally breaks, where Io moves in too far, Europa and Ganymede move out too far, and Laplace resonance breaks, then those orbits will drift towards circular, and then Io's volcanoes will go cold. Europa, by the way, has this enormous ocean or liquid water underneath its surface. We calculate the volume of water, liquid water, that's H2O, that's hot enough to be in liquid form, is about 5 times the volume of the oceans on Earth. So Europa has an enormous ocean underneath. Whether it's a ocean with an ice cap on it, like you might find in the Arctic sometimes, or it's a sort of a slurry, slushy thing, that's to be determined. But again, when the reason why Europa has liquid ocean is primarily also tidal flexing. The surface of ice on Europa moves up and down every 2 times 84 hours, a distance of 500 meters, right? So almost 1,600 feet.
That's a fair distance there.
Enormous tides going on inside the thing in this smaller core inside that has actually, interesting enough, has a magnetic field. The rocky core in the center is a magnetic field, and it's got this giant ball of water around it. The outside edge space is cold, so you get this ice crust. It's more like an egg, where the yolk is the rocky core that has a magnetic field, and the white is the liquid ocean, and then the shell is the frosty bits on the outside. So when Europa loses its circular orbit, then it will go cold and freeze over as well. By the way, there people talk about there's 4 Galilean moons of Jupiter. Io, Europa, Callisto, Ganymede, and Callisto. Callisto is not in a Laplace resonance. It's I mean, if you talk about that ratios, its ratio is like 9.4 or something or other. It's an oddball. What we think happened was that there probably was a case of a resonance where it had a 1 to 2 to 4 to 9 ratio, and the Callisto was the first of the big Galilean moons to break its resonance, and is now in that odd set. So we expect sometime now. The length of time that we think the resonance has to go is somewhere in the order of around 50 to 100 million years.
Oh, so just right around the corner.
Yeah, which says, are we just seeing it, or it's been that way for almost 4 billion years, and it's breaking just now, or does it go in and out? Because the question then becomes, okay, so they break free from this resonance, and their orbits go circular, and they go cold. What happens then? Does it just stay that way and permanently break and re-enter, or is there some other dynamic process that will get them back into a integral resonance? Again, it's that integral part that causes it. When you get 2 moons that are always passing at the same spot near each other, they tug on each other and cause their orbits to start to squish, right? So it's possible that after these orbital resonances break, it will drift around for a while and re-enter into a new resonance period. We don't know that. What we do know is it's breaking. And this came about because of a remarkable discovery. The Paris Observatory, an amazing institution, had really amazing photographs taken of Jupiter in around 1884. And those photographs are astounding, right? Today, astrophotographers would be proud to take photos that good, right?
Right.
And these folks back in 1884 had really accurate stuff. And not only that, they also had accurate clocks, and they had star fields around there. So we know, and they also photographed things like when the moon was coming in and out of Earth, Jupiter's shadow. So we have some very precise times of when and where those moons were. And we have this baseline of almost 117 years between those photos and today, and that's where we've been seeing these drift. Now, in that 14 years, Io moved in 40 kilometers. Europa moved out about 93 kilometers, and Ganymede moved out about 146 kilometers. So Ganymede is the one that's breaking the fastest. It's probably possible that Callisto, the one that's not there, broke first, then Ganymede, then Europa, and then finally Io. We don't know that, but that has profound impacts on if there's life in the oceans in Europa, which is one of the places I would, if you could be bets for finding life outside of Earth in our spacecraft, with people in it or not. That Europa is one of the places besides like Enceladus around Saturn and Mars that might have life. If it turns out the Europa is going in and out of this, resonance heaps up, non-resonance freezes, there might be less of a chance of it being able to develop life. But it's possible it's doing it once, it'll break, and we happen to be catching it near the end of its cycle.
Okay. Now, I want to quickly say hi to Bullinator, because he said hi and he's in the chat. Welcome. Always good to have you. So
excellent, Bullinator. Good to see you. And folks should check out Bullinator. Enables a lot of amazing stuff on this YouTube. He is a producer extraordinaire. Absolutely. And a lot of people owe a lot of thanks to Bullinator, because there's a lot of great shows put on by a lot of great people, and behind the scenes is Bullinator.
Yep.
So,
all right. So,
Bullinator.
Also, we had a question from Nestle20 about what it means for a black hole to rotate, because it's not obvious, I think, for a lot of people what it would mean for it to rotate. And it's one of the only, I guess, features or things of a black hole that we can detect from outside is rotation, mass, and charge.
Charge, yes. So it's three things: rotation, mass, and charge. And so, again, object becomes a black hole because it's dense enough that the gravitational field, escape velocity, exceeds the speed of light. But if an object is rotating and you compact it, it continues to rotate. In fact, you've seen ice skaters on ice where they have their arms out and they're rotating slowly, and they pull their arms in and they start spinning up. Same thing happens. Giant star is collapsing. As it collapses, it'll start spinning faster because conserving a little momentum. And by the time it gets to forming a neutron star, if it forms a neutron star, it might be rotating. We've seen neutron stars that are rotating where their surface, the equatorial surface is like 30-40% of the speed of light. It's presumed that what will happen as you go to extreme cases is that the object inside the horizon, the mass there, continues to rotate and rotates fairly fast. And the effects of that rotation still permeate through the event horizon, the short shield radius. But as Dapper said, mass, the gravitational field, the charge. So if it's got static charge, you'll see the electric fields coming out of it, and the rotation are three things you can detect and experience outside of a black hole. But I think you can't. But those are three things you can.
Now, if I remember correctly, and correct me if this is off, but at least based on the math, the idea is the singularity of a rotating black hole would actually take the shape of a loop with a hollow center. There's a hole in the middle, and it would also flatten out or make oblate the event horizon in such that the equatorial radius around the rotational axis, the equator there, would be actually a bit fatter than it would be from pole to pole on that rotation.
Yes. And so you'd have the effect. The effects would be, as you said, because that object that's inside, that the mass inside that has a black hole has an actual spin, axis spin, And so you expect that the event horizon around the equator will be a little bit fatter, and that around the poles will get a little, squashed a little bit. And in fact, if you somehow were able to spin that object up to near its surface, its equatorial surface area reaches close to the speed of light, then you'd have the event horizon be fairly fat at the equator and almost touching the object on its poles. You get really weird things starting to happen as you approach space gets twisted. It won't actually reach the speed of light and on its angular speed at the equator, and no doubt some weird physics happens as you approach that extreme. That's part of the reason why it's starting imaging these black hole shadows, like they did with that one supermassive black hole in the galaxy, where they imaged the shadow of the black hole region, is to try to understand more and do some direct observations about what's happening, because it would be nice to see the effects of a very rapidly rotating black hole versus one that's mildly rotating.
Right. Okay. Well, I hope that answers that question. It is really a really interesting question, because normally I think a lot of people think of black holes as basically just a singular point with no real component parts that doesn't do anything except exist. And that's not really true. Black holes are actually, they do a fair bit of stuff. Although sorry, go ahead.
Go ahead. No, please go ahead.
Okay.
Go ahead.
I do also seem to remember that black holes typically do not maintain a net positive or negative electrical charge, because once they acquire one, it's very likely that they'll attract particles of the opposite charge and then simply go back to being net neutral.
Yeah, but the charge anomalies can permeate through that surface.
And we have a question from Boole, which is, what element does the matter entering a black hole become? It's obviously not on the periodic table. I believe that, at least, so assuming we can talk about getting to the event, or to the singularity, which isn't something that you can observe from the universe's timescale, but you would observe if you were falling in, I believe it would just simply go beyond the Pauli limit and become something that we don't have a good explanation for, as far as, I don't think we could call it an element, could we?
Yeah, I mean, because let's take a simpler case of a neutron star. You can say, well, why do we call it a neutron star? Because the nuclear material reaches this exceeds its degenerative pressure, and all of a sudden the electron shells can't hold enormous pressure, and so the nucleuses of those atoms kind of get smashed together. Now, it's not quite correct to say it becomes a giant atom, but in some ways it effectively does. Inside a neutron star, theoretical models talk about the inside of it being kind of this quark soup, and in the mantle would become sort of this thing of these nucleons in this sort of this weird sort of nuclear fluid, and the outside edge is actually electrons and protons. So the exterior shell of a neutron star actually has enormous magnetic fields get generated, because these currents of these charged particles around the surface are generating enormous magnetic fields. And so some of our strongest magnetic fields we've detected come from neutron stars, rotating bodies with all these charges. And so something like, if you look at the Crab Nebula, Messier 1 and up in the sky, it's one of my favorite northern hemisphere objects. It is a nebula whose glow is being generated from this rotating field, a star that collapsed in 1054. You have people that observed this star going supernova. It was bright enough to be seen in the daytime for several weeks. It collapsed into a neutron star that now rotates at about 30 times a second. And the magnetic field generated from the charges rolling around the surface of it creates an enormous spiraling magnetic field that causes electrons to accelerate out, and they actually give off a glow as they're moving almost relativistically through this nebula, and it causes the nebula to glow in a fairly dramatic form. In fact, with a moderate-sized telescope and a rotating shutter that I've done, like on the Fremont peak, 0.8 meter, you can have a little rotating shutter, a little fan blade turned about 31 hertz, just slightly off from the 30 hertz spin of the Cravitational pulsar, and you can see the wagon wheel effect. You can see the star pulsing in and out in real time. So, based on those, we would expect that you'd have similar extreme processes that can occur if it were get dense enough to form a black hole. It's not quite effective to say it becomes a single atom. It becomes basically a number of shells. Again, likely the interior might be some weird quarks type stuff at high pressures. The mantle certainly has neutrons, and it's sort of this weird neutron soup. And then outside edge would have these charged particles. As far as what happens inside the black hole, we don't know. Here, we have very good observational evidence from neutron stars as to what's happening on the surface and just under the surface. We don't know quite about the interior and inside. Black holes are harder to go. I am not one that thinks the hypothesis of this so-called singularity, these infinite point things, is anything other than a mathematical description of something. We have no evidence that a singularity actually exists inside a black hole event horizon. There are some people who presume that, and some people have arguments where they say, what could stop it? As is, we don't know in the extreme conditions that could occur in extreme densities of a black hole as to what new things come into play. So I tend to think more that the object inside, the mass inside a black hole, is not a point source, but has some other high density system that is a state of matter that we don't really understand. It's quite hard to understand because in order to create it, you have to create a black hole, which means you have very little information coming out other than the outside effects of mass, charge, and spin.
Yeah.
So it's kind of hard to tell what it is, but to assume it's a point-sized thing in the interior, I think is presumptive.
Well, we also have a question asking, what would happen if two black holes were to come together? Now, as far as I know, their masses, spins, and charge some, but I don't know much else besides that.
Well, it's a good question. So we've detected black holes merging. The LIGO, gravitational wave, not gravity wave. Gravity waves are things that you can see in the sky from pulses of weather stuff. But the gravitational wave that come from two black holes sparring down in and merging are being detected on a fairly regular basis by now these things like LIGO, Virgo, gravitational wave detectors, and so we know that they merge, and we've detected them now. It's an amazing engineering feat to build detectors that can detect the ripple of space over, let's say, a 4-kilometer bar that moves like 1,000th of the diameter of a proton. It's an amazing feat, but they're able to do that. The thing we try to simulate, and I've worked on trying to simulate mergers of black holes. It's very, very difficult. You get a lot of divide by zeros, which doesn't help you in your numerical calculations. We're able to do neutron stars merging to form another neutron star. That the physics is relatively tame. But when neutron stars merge and form a black hole, or when black holes merge, in the process where they're getting close to each other, the midpoints in between where the two black hole event horizons are not quite touching, the space inside there gets really twisted and warped, and it's very, 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 very difficult to try to simulate anything with any semblance of mathematical accuracy. So it's extraordinarily hard, and you have to do a lot of assumptions, a lot of hand waving, which at the end point you say, are you simulating anything that's close to reality? Right. We know that black holes merge. Some of the precise details of what happens to the surface boundaries as their surface boundaries touch are really active areas of research in relativistic work. But we know from neutron stars that one of the things is that it isn't a case of just two billiard balls spiraling each other and go loop. One of the things is that the space gets so warped that, for example, the time. Imagine, the time in the front of one of the neutron stars is running at a very different rate than at the back, right? Because the neutron star in the front is feeling fairly significant gravitational forces from the other neutron star. Or in the case of, again, talk about neutron stars are the easier least to conceive. So the clock at the front of the neutron star is running at a very different rate than the clocks at the back. Which means if you start off with something relatively circular, that thing starts to twist. And the shape, best way I can describe the shape of them, if you know what a yellow crookneck squash looks like in the produce market, you get this blob with this little out the side, this little handle outside. Well, that's what the neutron star starts doing. The front of it, as it's getting close to merging, has this bulge that's kind of flattened, and like at the end of a gourd, and the neck of it comes off. That's sort of trailing because it's got a time period where it's seeing the gravitational field where the thing was a little while ago because its time is being warped at a different rate, and so the object gets relatively weird time dilation where the front of it merges, the back of it is not merging. In fact, the back of it gets a recoil. So what happens is when the two blobs merge finally, the tails snap off and recoil. And so not only do the two blobs have a big smash, but their tail ends recoil and snap off and fling out at nearly the speed of light. So one of the things that happens when neutron stars merge is you get a fairly significant percentage, 10-15% of the mass in neutrons get flung out radially from the orbits at nearly the speed of light, and those neutrons fly out and they come up basically comes out in a spray that kind of goes in all directions. This shower of neutrons, and those free neutrons poot out and to the point where they then they're in free space, and neutrons in free space then decay. I think the half-life is roughly 1,000 seconds or so. So those neutrons start to decay into protons, electrons, and antineutrinos. And so you get this whole burst of radiation that comes from these neutrons fleeing out and decaying as the inside turns into whatever it turns into, a neutron star or a black hole or other weird things.
Okay.
Space gets really twisted, and when you start trying to do the simulation, you start looking at the grid lines. The grid lines just get really weird eddies and twists and so forth, and space gets very confused. Objects, however, do merge. We know that black holes merge and neutron stars merge. We've seen neutron stars. We detected neutron stars merging with the detectors, not as frequently as black holes. They do merge, and there's probably lots of weird details we don't quite yet understand. But it's an important thing going on in space. There are objects, strange objects, that do strange things.
All right. Now, we also wanted to mention that for the first time in 20 years or something, the United States now has United States operated manned spacecraft.
Yes, the space shuttle program didn't end around 12 years ago. Wasn't it around that time?
Something like that. Yeah, I was exaggerating with 20, but yeah, it was for the first time in over a decade.
Yeah, and so we've had first time in that period of time that people were launched from the U.S. from a U.S.-based spacecraft. Now, what's been happening is that countries like Russia and China have been launching people, but the U.S. has not been. And this is not something like a USA must be in there. It's that I think mankind, people kind, whatever kind, creatures of the earth benefit from they're all being produced are working towards exploring space.
Yeah. And
so really what the thing was that the US was not participating in contributing to space exploration in terms of human spaceflight as much as it should. And different countries find better ways to do certain things, and we learn from it. We certainly know that the masters of human spaceflight were the Soviet Union, now Russia. I mean, they are the most prolific launchers of people in space, and they have a lot of experience in their technology works very well. There are better ways to do it, and I think the current SpaceX NASA hybrid system is something that's bringing forward, I think, some really good new levels of technology. There was in NASA the Apollo era for its time had amazing tech, but some of that technology has kind of stayed in that 1960s, 70s timeframe and not progressed as much. In part, there wasn't a reason to. In part, it was expensive. And so the addition of commercial space flight is bringing some of the new technologies and modernizing some of the things. Again, I'm not criticizing the Apollo era stuff. They did one of the most extraordinary things that has been done by planet Earth in a long time. The value is that we now have new technology and upgrades, right? It's and new possibilities coming forward. I'm still am a big firm believer that the majority of space exploration needs to be done with robots, because people create getting people in and out of space takes an enormous amount of resources, and the time and durations are such that they're fairly limited right now in what they can do. I look forward to people returning to the moon, and I look forward to people being able to operate a moon base, operate telescopes on the moon, which will be very important for exploring space, and then progressing towards places like Mars, provided that we have enough robots that go to Mars, explore it first before people go there and contaminate it.
Right.
That's my wish.
What kind of time frame do you think is realistic for that moon base? Because people have been putting around numbers, and some of them sound rather optimistic to me, but I don't actually have a firm grasp on all the engineering and logistics challenges. So it's really
no doubt there'll probably be moon landings, within this decade. The thing that is, or to say the coming decade, because we're still in the
we're still in the
decade,
teens.
And so the coming decade of 2021 to 2030, most likely we'll see moon landings there. And during that time, there'll be sort of the first stretch projects to get people back to the moon. But the question is, operating a permanent moon base, I think, is towards the end of next decade, where we still have a little less than 6 months for this decade to go. So unlikely we'll see a person landing on the moon in this decade, but the next decade just about to start.
What if China has their secret launch to the moon that no one knew about, and they just show up with a flag? Then
people who are into flags have to deal with that.
It does seem unlikely, because I feel like you would notice if a lunar capable man mission were launched from China, because there's satellites everywhere.
Well, also they would brag about it, right? They wouldn't want to keep it secret. So I think the next decade that's about to start, we will see people returning to the surface of the moon. First with some limited stuff, but to set up a permanent moon base where you can have, by the end of next decade, permanent presence of people on the moon. And that's going to do some enormous stuff for exploration of space, enormous important platform to which to explore the moon and learn about Earth-Moon geology and history, as well as a great observational site for telescopes. I want to see optical telescopes that go from mid-infrared up into ultraviolet, and also X-ray telescopes operating on the moon. Stable platform, and it depending to speak of. That'll be a little bit of a problem as people start going on the moon frequently, as we'll kick up dust. But relatively speaking, that's a relatively minor problem than with respect to our atmosphere and all this dust that goes around.
We have dust storms, and there's humidity and all sorts of pressure changes. a little bit of dust going up into the exosphere on the moon seems like a fairly minor thing when you compare it to that.
Yeah. And of course, so the moon is one of the bases that is relatively nearby. I mean, in terms of light, it's only 1.25 seconds one way, so 2.5 seconds round trip. The moon, so the moon will be again a situation where it's relatively tethered to the Earth. The thing that we have to develop is spaceflight with people or biological stuff that doesn't depend upon resupplies from the Earth. Right now, the International Space Station requires a constant supply of fuel, air, food, and then retrieve the waste back down into this. It's tethered to Earth. And if we stop servicing this International Space Station, they'll have to abandon it. The same sort of thing that with the moon in our current technology is that food, fuel, air, water, so forth, right now has to be delivered. Exploring the moon, and particularly in places like near the moon's south pole, has a possibility of finding resources on the moon that we think we've detected ice inside deep craters in the moon that could be mined rather than sent from Earth. But the big thing is to build a spacecraft where you have a biosphere, where you have a self-contained system that can operate over a long period of time. The expensive difficulty of getting to a place like Mars is that unless you have some of these self-contained systems, or you land on Mars and build your environment and build your food and build your water distribution systems, you're going to have this constant, very expensive supply of space, trucks moving back and forth. So the intermediate stage would be say, well, go to the moon because we can keep supplying it. A little bit expensive, but we can supply it. We can develop longer-term spaceflight capabilities, and then go out to the some of the nearby asteroids. So there are asteroids that are, they're not just between Mars and Jupiter. There are plenty of asteroids between Earth and Mars that we could go to and explore as well, and again, develop the technology for long-term space flights. Nothing to take away from the Apollo missions that landed on the moon, but they were essentially self-contained Earth bubbles with enough food and water and waste storage that they could survive the trip there and back. They weren't permanent. They were not self-sustaining. We need to be able to put a terrarium up in space and have it operate on its own rather than keep supplying it if we want biological stuff out there farther.
So we have a question that I just noticed, and I think I did miss a few questions, but coming up in probably
ask them again.
Yeah, coming up, especially in about a half an hour, we're just going to go to straight.
Let's go to the rapid question and answer stuff.
Okay, so TP Seeker says, should we use the Mars for a launch pad? Should we use the moon for a launch pad to go to Mars, or should we just go to Mars straight from Earth? I am personally skeptical of the whole idea of getting to the moon and then going. And for me, the big reason is it takes delta V to capture into orbit around the moon that you could have just not expended in capture. You could have just gone straight there. But I can see the argument that if we're going to construct an especially massive spaceship, then constructing it in orbit around the moon might make some sense.
Particularly from materials mined from the moon.
Right.
So that is there's value in having a moon base just in terms of being on the moon. But there's also, if you're talking about using it as a jumping spot, materials mined from the moon, building a large spacecraft around the moon is going to be less gravitationally difficult than doing it from Earth with an atmosphere. That's provided you solve the problems of people on long spaceflight. The issues of radiation, the issues of bone loss, the issues of macular degeneration in their eyes, the issues of the early onset of Alzheimer's, which are being worked on, which is why the International Space Station is important, which is why things like SpaceX being one of the places that they can send stuff back and forth, and the cargo, commercial cargo, as well as people going back and forth are important, because that platform of the International Space Station we're learning an extraordinary amount of information about what's going to take to do viable long-term spaceflight. And the moon will be another great base for us to have. And there we're going to learn about mining. We're going to learn about how to use resources of another body. Because so far, everything's come from Earth. And we picked up a few rocks and brought them back. But everything's come from Earth.
Not exactly an
Earth-based.
industrial strip mine operation.
No. And so the development of commercial mining of asteroids that are nearby Earth will be another kind of a proving step that we'll learn from there.
Yeah. So we also have from Nestle 20, would nuclear energy be necessary? I think this is the context of long-term spaceflight. I think so, since energy storage from solar for half a month is really extreme. I tend to think that so that there's a one big complication with nuclear energy in space, which is that there are a lot of treaties that restrict exactly what you can do with nuclear technology in space. We have sent small reactor-powered things, like I believe the Cassini probes and stuff like that. They had nuclear reactors as their main power source because they were going beyond the effective range of solar panels, if I remember. But I think from a practical standpoint, yes, you're going to need nuclear power. You might get solar panels as a supplement.
Yes.
There's no reason to ignore all those photons falling on the moon.
But the thing that is so there's two types of sort of generally 2 or 3 types of nuclear processing that goes on in space. The first one is you have a nuclear reactor up there. The second one are radioisotopes, basically materials that are radioactive decaying, and the heat from the decay is turned into electricity. Third one are sort of various exotic forms of nuclear propulsion. But that's off a way. So, but mostly what you see, the nuclear that's being done in deep space are from space probes with basically they have a blob of radioactive material that the heat from the radiation keeps the spacecraft warm and generates electricity. That's how things like the Voyager spacecraft after 40 years are still operating.
Right.
The thing that is that the reason why solar is not viable out much beyond Mars is that that as you get farther from the sun gets fainter, and you have to have bigger and bigger solar arrays to collect the same amount of material. By the time you get out to Jupiter, solar is relatively useless. The sun is too weak, and the massive size you need for solar panels, for high efficiency solar panels, is just too much stuff.
Let's say for the application of the moon base.
Yeah, in the moon base, sure, solar panels can be a good thing to operate on the moon. And you need to have just like on Earth, you need to have a storage system, because on the moon, half the month the sun isn't shining.
Right. So we've got a 14 or so day period of no solar power coming in.
Yeah, most likely a moon base would be more effective underground, right? Most likely you'll have some sort of landing platform and structure, but you want to dig underground. One of the reasons is that the moon doesn't have much of a magnetic field, and so you're exposed to solar bursts from the sun, and high energy particle radiation and X-rays and so forth that hit you. Where as a Apollo astronaut for a couple of days, you can tough it and hope the sun doesn't give a good burst. But if you're on the moon for a long period of time, you want to be underground, get some shielding there. But then above ground, you can put solar panels to collect energy. So if I were operating an optical telescope on the surface of the moon, I would have solar panels as a means to do that. That being said, those solar panels are subject to decay from space stuff, and we'll learn a lot better. We'll learn a lot by operating solar panels on the moon, because the International Space Station is relatively close to the Earth and is inside some of its magnetic bubble, if you will, the magnetosphere. Yeah. On the moon, you're outside of that thing, and so there we'll learn about how to handle materials that can survive the space weathering for a long time.
So we have by the way, Ilya Moon's in the chat, along with Punchy. So
Hey,
Ilya, put your link to the channel where you're starting all those new shows on, because Ilya Moon and Punchy and Mr. Sirius and I don't remember who the fourth person is, but they're starting a bunch of new shows on Ilya's channel. Ilya, get that in there, and everyone,
yeah, get your channel on there. You
go,
get
go check
stuff.
that out, because I think those will sound like they're going to be some interesting stuff going on there. So and it was pointed out that there's a ban on nuclear weapons in space, not nuclear power. I do know that there's a ban on nuclear weapons. I'm just not sure to what extent it affects sustained reactors, where you're doing things like inducing fission. It doesn't ban sending up lumps of whatever it is.
Laboratory material. People get nervous about building a reactor and launching it on a spacecraft. That's because sometimes the launches don't go well.
Yeah, normally I'm a big fan of pointing out how extremely safe nuclear power is. It's by far the safest power generation technology on Earth. Even when you take into account the accidents that have occurred, it still kills far fewer people per megawatt hour generated than solar or wind power does, which is the next lowest. Wind power is about an order of magnitude more deadly than nuclear power on Earth. But when you get into a situation where a significant fraction of launches end up with an explosion, and there's a nuclear reactor sitting on that rocket, that becomes a little bit more iffy.
So that's the case. That's the failure of the building, not the reactor inside. But still, there are developed protocols of the radioisotope generators that get launched into deep spacecraft, where they have things that can survive a rocket and reentry.
Yeah.
Intact, right? That's an easier system than to building a large reactor. But that being said, if you're going away from the sun, by away from the sun being much, even at Mars, you're kind of stretching it, but much beyond Mars, you can't count on the strength of the sunlight to do much for you. It gets pretty weak out there, so you need alternative fuel sources.
So, Nusuk20 asks, would the power storage requirements for 14 days of darkness on a solar-powered base be, would that be a big problem? It seems like that would be a lot of batteries. And my quick thing is, I doubt that it would primarily be based on batteries. I think a more likely thing would be using, like a centrifuge system where you spin up a block of metal.
Inertial things, also ultra capacitors.
Yeah.
Charge plates and so forth. There are various things you can do that can keep you going in terms of storage systems. And that's one of the things to look at in the scale of a moon base would be something that could handle capture, because you got to capture enough during your 14 days or so of sunlight that you can operate in that 14 days and have losses in your storage system and keep it going during nighttime.
Yeah. And actually, I doubt very much that industrial scale batteries would be a part of any moon base. And here's my big reason why. The reason that large scale battery banks work on Earth is basically because you can ventilate those rooms and have output that goes straight up into the atmosphere and input taking from this essentially infinite resource of fresh air. And the reason for that is that you get hydrogen buildup in battery rooms if you don't have them sufficiently ventilated. And that's just a result of the chemical interactions that are going on inside the cells, where you have acids sitting in with all these metals and things, and hydrogen just starts to build up. When you have a situation where you would have to take all of that hydrogen and sequester it somehow inside the base, and you cannot simply reliably always get fresh air from outside because the outside is the inside. There is no outside air on a moon base. I think that would become prohibitively risky in terms of an explosion. And an explosion on a moon base would be a catastrophe.
So what you have to do for contained battery systems is have a hydrogen trap system and plating process that would have to go there, which would take power, which reduces the efficiency of batteries.
Yeah. That's why I think things like capacitors and rotational energy would be probably the preferred method. But I'm not the engineer working on it, so I don't know.
And again, I think these are things that why going to the moon and developing a moon base is going to give us some more useful work in understanding about spaceflight and deep spaceflight. Also, having non a non-zero or having some form of gravity, not microgravity environment in a space station, but operating in that is a useful thing to understand. Yeah. Also, understanding the issue of dust that you'll find when you go to asteroids as well as the moon, and handling that is another thing to consider.
All right, so Rodent No Last Name says you could put up low lunar orbit power. I think it's supposed to say relays to beam power down at night. X34, which I'm not sure what that is working on power beaming technology. That's certainly an option. One problem though is that lunar orbits do not last very long. The moon has an extremely irregular gravity field because of the rather extreme changes in density under the surface, as well as just the height of various surface features.
It's not a uniform billiard ball. It's actually quite low.
It's so one of the problems with you can't basically put up a permanent satellite in orbit of the moon. On the order of years, it is going to crash. So I doubt that something in lunar orbit would be realistic. But if you could put up, say, a network of satellites that maintain, a fairly even spacing around Earth, and then beam power from Earth to the near side of the moon, that might work. But then you get problems with like dispersal of the beam. So I don't know is the answer there. It's not impossible, but I see a lot of challenges with it. I think that realistically, at least for the foreseeable future, if we want to get power on the moon, we're going to have to generate it and store it on the moon.
And a case on the moon is that probably the best sources of power coming into the moon is sunlight. Yeah. During the time where it's actually
now, maybe we could do some nuclear based backup, even if it's just as simple as sending up a big chunk of something that's radioactive and say, okay,
yeah,
here you go. We got a thermoelectric cell and a heat source. It'll last you for the next 50 years.
Yeah, and so those are radioisotope generators is what we were talking about. And again, usually in your power systems, every power source has its pluses and minuses, has its benefits and its detriment. And so having a power system that doesn't rely on one technology, where a failure doesn't knock out everything, where you have a variety of stuff, is probably the more practical system. I mean, that's what we do here on Earth. We don't have just one power source. We have many power sources that serves us well. I think it would on the moon would be the similar sort of thing. And again, learning about this
on the moon with all my eggs in one basket when it comes to power.
Yeah, exactly.
And Rodent No Last Name also points out that L5 or other Lagrange points might work for power sats. Yeah, that's also true. So one thing you could do is you could put a relay station at the Lagrange point between the Earth and the moon and try to beam power to that. That would seriously reduce like dispersal problems in terms of power. So that's certainly a possibility for power transfer.
Sure.
I mean, so yeah, there are a lot of things that we could do. I think the primary source of power is still going to be solar power from solar panels on the lunar surface that is then stored in a number of ways and not primarily in large-scale battery banks. Because I think that the hydrogen problem is probably so big that the ways that you could solve it wouldn't be worth storing it in batteries when you could just do things like spin up a steel rod or charge some capacitor banks.
Sure.
So I think that's now, of course, I'm not an engineer working on this, so I mean, you have to take this with a grain of salt. This is essentially all coming from my training to be a nuclear electrician in the Navy.
Sure.
I mean,
well, that's a pretty good training.
Oh, it is. It's quite.
The Navy has Navy has an amazing nuclear program.
They do, although it's also been a while since I was in it. So, actually, I was looking back, and it's been about 10 years since I got out. I've been out for significantly longer than I was ever in, which
Ah,
is a weird
wow.
thing. I remember
I
when I hit that point where I just had been out longer than I had been in, and it was a weird feeling. It was a few years ago.
Well, I was never in the Navy. I did have a opportunity for, and I took advantage of being on an Ohio class submarine that was part of there was a scientific and naval experiment that I got to go on for an extended period of time, and it was amazing to see that system in action. Right, highly competent crew of people that really knew what they were doing. I was quite impressed, except for some of the mid-level officers. The guy in charge of it, the captain, was an amazing person, and the people who ran the sub did an amazing job. There were these people in the middle whose job seems to be screaming at people for no other reason, and then they could yell. They were kind of wastes of oxygen, but for the most part,
to junior officers.
Yes.
Yeah. I would be completely okay with getting rid of junior officers and just saying, hey, just pull your, like mid-level officers like 03 and above just from the senior enlisted ranks after those people get whatever degree they need.
Yeah.
But I'm not in charge of any of that. But yeah, JOs are basically a waste of oxygen.
Sorry. I there are a couple people that were nice on the kinds, but I didn't see how they were adding value.
Look, I've met plenty of personable JOs. That doesn't mean they were useful to anyone.
And but on the other hand, it was a case where I know that the captain sort of said, while we're on this voyage, Landon gets to ask anyone any question, and you have the obligation to answer it in a way that's commensurate with his need to know. Right. So I could ask anything, and they could respond. You don't need to know that, blah blah blah. But you ask somebody about that, they could tell you the bolts on this thing and what the bolts are and what that light was and what this thing is, from rote memory. But when the screaming people came in, they tended to yell about stuff that sometimes was not even me. Because there was a case where I just asked again, by the way, what does these things do? And someone else and explain, and then this screaming person comes in asking for something I know is actually not even there, right? He's complaining about something that isn't there, not being right. And the mode was to do all the yes sirs and watch this thing happen, and the person leaves and they go back to doing what they did, right?
Yeah.
It's like, basically. What was the point of that?
There wasn't one, really.
Yeah. But needless to say, but the nuclear systems in there that were both reactor and the thingies that were contained in tubes that would hopefully never launch but could. Those people I was very, very, very impressed with their knowledge, skill, and ingenuity, right?
All right. Well, we have a question, which is from TD Lane. Would it be possible to have Landon as a special guest for a future Kent with Bent? I don't see a particular problem with it. I believe Landon and Bent would both have to be okay with it, and it would probably have to depend on what Kent was going to discuss, because I think most of what Kent discusses is probably, or not most of it necessarily, but a good chunk of it. I don't know if it would be interesting to you, Landon. A lot of it is stuff like geology of like flood geology and paleontology stuff.
Well, I was on a thing where we talked about Big Bang cosmology.
Yes.
And I missed because of some signals there being on with Crockett about nuclear solar synthesis and solar chemistry. So I've had at least one. I've had two invites, one of which I was able to attend, and one which, because of signals crossed, I missed.
Yeah. So you have done some creationist stuff. Even I think our first show, one of the things we went over was various creationist attempts to account for astronomical observations, and why each of them fails extremely quickly at even the most minor amount of investigation.
And so you asked about Kent Hovind, Kent Ham, those that Mr. Gish Gallup, all that sort of thing. That group of people are not into debating. They're into rhetoric.
Yeah.
And so it's like debating a brick wall, and you can predict what they're going to say, you predict how they're going to react, and there's relatively little value. I would prefer instead to talk about what we know and let those charlatans and people that have committed intellectual suicide do their thing and not give them a platform. I mean, I don't.
Oh, sorry.
That's my opinion.
Yeah.
But
I have been informed by Bent Hovind, no relation, that Bent is okay with Landon on Kent with Bent. So
yeah,
we'll have to find a I want to find a talk that I think is going to be particularly good to have you on, because I don't want to have you on and then Kent goes on about like dinosaurs or something, because I feel like you would be much better used as a guest on something where he's talking about, you know, like hydroplate theory or the ice canopy or something to do with like planetary science or space or something,
sure.
right?
And I could talk about what we know and what we're studying and latest finds on there. But you know, it's like when encounter people that are into flat Earth, it's like there isn't really a point in debating those people.
Oh no.
And in fact, in some ways, it gives them a platform they don't deserve. So I'd rather talk about how I measure the distance of the sun, how I measure the size of the Earth. How do we measure the distance of the stars? How do we understand the age age of the Earth, those sorts of things. Those are things we can talk about I think in great detail. That debating people that go from somewhere between being silly to having committed intellectual suicide, it's not a useful
all right, well,
not a useful process. But I'd love to be on Benthoven and discuss stuff and discuss what we know.
Okay, so I've got a couple things. Robert Edson says there are chemistries that don't generate hydrogen. There are they do have their own failings. There is, for instance, there's a reason why they are not very common in industrial use, where except where they have to be. They tend to just not be quite as good as batteries. So
and many for example, in electric car systems, the battery plants have ventilation, right?
Yeah.
You do not have complete closed systems where you would get inside, turn on a switch, and the car goes boom, right? Because you built up hydrogen. Hydrogen is a fairly nasty gas to deal with. It's extraordinarily leaky, and it's reactive, and it's a pain in the.
And Rodin, no last name, says X-34 is the mini unmanned shuttle that the Air Force has been launching. Oh yeah, and leaving it in orbit for a year. It's the one with that weird offset engine.
Yep.
Yeah, I forgot about that thing. Yeah, well, I forget about it because its launches are almost all secret. They don't publicize them. You can't go.
They're doing Air Force thingies. So in that sense, and on occasion, we've gotten some of their optics from some of their mirrors that we would, for example, there's one nice mirror that can be turned into a nice space telescope that will, eventually launch there. So they have some good stuff up there. I just don't know much about it.
And Robert Esses points out, lithium ions are common. They are also significantly more expensive. So there are still questions. Is lithium ion going to be as effective as just charging up some capacitors? Maybe it is. Maybe a bank of lithium ion batteries are a realistic option.
And particularly, the issue with lithium ion is how you manage the batteries. And they're not forever, right? So there's replacement cycles, but how you charge and discharge them and monitor them is key. And that's the difference between an electric shaver that's going to last for 10 years and one's going to last for 8 months, right? Yeah. There's battery systems that are good and battery systems that are poor, and how you charge and discharge them and the rates of charging and discharging are key to the life of the battery. That being said, on a moon base, you want to have, I think, a multimodal system. I think you want to have things converting sunlight, things that are using radioisotope decay, storage systems like charge, inertial, and chemical, right? A combination of those things. As well as you're there to learn about how those things will operate in space and the problems at scale.
Yeah. Well, and the thing is, I fully expect that there will be various kinds of batteries powering things and stuff like that. I'm just skeptical that it will be the main source of power storage for the base as a whole for 2 weeks. I think that generally speaking, batteries are not your best bet for 2 weeks worth of energy storage for a host of reasons.
Yeah. Now, we have some pretty good experience in Antarctica where you have a 6-month night and they operate without solar stuff. And so we've have some pretty good, skills with low temperature, obnoxious environment configurations over 6 months time.
But isn't there energy storage usually chemical?
Yes, but there also are other systems that are being used in those areas because the chemical stuff, like when we're out in the field in Antarctica, one of our primary sources is propane, but that's only limited supply, right? And once it's gone, sort of thing. So you have to ration that thing. But the other systems that they use there can be now. Antarctica just no longer has any nuclear power plants there, but there are other power systems and inertial systems and charge capacitors are things that are being used in various places for stuff. We've been gaining experience there, so that's probably going in Antarctica being in sort of that bubble of survivability that you surround yourself with is called a bunny suit or a station. It's kind of sort of akin to being out in outer space, right? That's I guess the best way to do it. And stepping out of that airplane onto the ice at the pole is like doing a spacewalk, right? And
it's a pretty extreme environment, yeah.
But if you keep your wits about it and you have a protocol, it's relatively safe. But we've gained a lot of experience from the Antarctic high altitude, low temperature environments. But I say that like the one system that I was in where people complaining because it was cold by Antarctic standards.
Goodness, that must have been extreme.
There's cold like you might have in Boston, right? And then there's cold that Minnesotans might think is cold. But then there's Antarctic cold, and the expression that's used, as some people at this one base they use actually a northern hemisphere. They refer to it as colder than a well digger's rump in the Klondike, is what they would say. That's the polite way of saying it. There's another way of saying it that's even more
got it.
More terse. But although my experience at time, I learned to give the temperature in Kelvin because you have a few of those left around. And I would say, I remember saying something like, what's your complaint? We almost have 200 Kelvin here. I mean, what's I mean, you got 200. You have plenty of Kelvin to go around, right?
We got a long way to go before molecular movement stops, boys. Good to know.
But again, those things about mechanical systems, electrical systems, life supplies, staying healthy, those sort of things are there is experience in Antarctica that has actually been quite useful in there. And again, when you're in that bubbles thing, it's kind of like you're in the spacesuit stuff. It's fun.
Someone did point out, I don't remember who it was, and it went past, but someone pointed out that Drunken Landon on Kent with Bent might be hilarious, which I will point out. We do technically have a drinking game that we do not encourage people to play, but they can if they want to.
And what does the game involve?
So the game is you take a drink, which is a self-administered amount of whatever your beverage is. Mm-hmm. Yes, there's not a rule about that. But we drink whenever Kent Hovind gets a point of fact correct without it being a direct quotation from someone else. So he has to get it on his own merit. We take a drink in celebration for Kent getting one. Any of the panel members can simply call it it's a drink time because whatever was said was so stupid that we need to drink to kind of dull the mental anguish. Also, if Kent tells a joke and just no one laughs, we take a drink. And then we do have some random triggers that come in on the basis of Toho kaiju noises.
Oh.
So yeah.
So I mean, I'd certainly have the sort of the Disneyland thing here that we can do for something like that.
And copyright struck.
And Yeah, that might be a trademark thing. And
trademark,
of course, I have some French liqueur. I have we could go for some Copperworks whiskey from Seattle, or I could go for some Larceny bourbon, or
you
if it
got a
gets
lot of
really
options.
good, the Grappa, right, from Italy.
See, I usually just drink a rum and Coke.
I used to have rum and Coke. I do have actually rum, but Coke is a vile substance, and I that back when there was two internet personalities used to have these rum and Coke nights, I got those little mini 6-packs, but I've long since dispensed that. So yes, we could do a drinking game. Give me the rules, then I can.
I will try to make sure that we get a good for Landon video where you can really dig into, like how we know what we know and why we know that for that reason the lunacy being spewed forth on air is in fact lunacy.
Yeah, and I like to talk about educating stuff as well, and what we do know and how we know.
Oh yeah, definitely. Well, that's a big part of it. Is we get a topic from the misunderstanding that's present on air, and then from that misunderstanding we say, okay, well, what do we know? How do we know about these things? And what have we learned about this? And
yeah. But back to space exploration. So Antarctica is actually used for some of the space training there, and also some spacecraft stuff, because spacecraft material science has been certainly explored and developed well in Antarctica. Dry, low temperature, high altitude environments that have some unique challenges.
Okay. So we also have a slight correction. I had said that this is from Rodent No last time. I had said the L5 relay would be, satellite would be a relay. The actual idea was that it'd be a solar panel that was always just generating power and beaming it straight there. And yeah, maybe that would be I don't know if it would be a main source or a supplement or what, but that's certainly something that I think is a possibility at least.
Okay. So to help for the chat, so if the chat decides, picks between French liqueur, single malt whiskey, bourbon, or grappa, right? So again, you have this French liqueur from the French Polynesia. You have Copperworks from the Seattle. You have bourbon from Kentucky, or you have grappa, wonderful grappa from Italy, right?
To vote in the chat.
Vote in the chat.
Actually, you know what I can do? I will put that up as a community poll.
Yeah.
And then people can just vote. So that way we don't have to try and tally up things in the chat, because that'll be a little bit annoying. Yeah. So stand by, and what I'm going to do is, after we finish this, I'm going to have Landon send me the list so I get it exactly right, and then go put those as options in a community poll. So check out my community tab in, I don't know, an hour or so. I can pretty much guarantee it'll be up by then. So, and we might even just slightly interrupt our current flow, because we've been going through the ridiculously long series of videos. But I think what I'll actually do is I'll find something that's particularly on topic for cosmology, astronomy, planetary science, stuff like that. And I don't know if you want to do this. So our next one is we do them Tuesdays at 6 Pacific. So I don't.
Tuesday at 18 Pacific. Let me look to see. So I have June 9th available.
Okay.
Or June 16th. So that's being the case.
Let me know which one would be better, and I can make sure that we make that happen. So there you go. Looks like our next, either the next or the one after, Kent with Bent, is going to have special guest Landon Knoll. So make sure you tune in for that. And we are getting close to that time when it is about time to start wrapping up and getting any final questions. So let's see. We had a question a while back, and I forgot to ask it. But Landon, are there any misunderstandings about cosmology that you find particularly annoying?
I think. Well, annoying is, I think one of the common things that people make mistakes on it. They talk about the universe and the visible universe, right? They talk about saying, well, at this time, they would say the universe was 1,100 times smaller.
Mm-hmm.
And the answer, what they really mean is the visible universe today was 1,100 times smaller back 387,000 or 378,000 years after the Big Bang.
Right.
So they miss a key phrase, visible universe, when they talk about the size of the universe. The universe actually might be infinite, and just the scale has changed. Another thing I think that's common, an unfortunate misconception, is it goes like this. You sit there and say, well, here's an object and it is 1 billion light years away. So it took light 1 billion years to reach us. And if someone says, well, what does it look like now? And I have to come back and say, well, it looks like as we see it now. Well, what about them? Because it's light's traveled 1 billion years. What's happening there now? Well, there now is our now, and our now is as we see it now. Oh no, what do you mean if you're there? Well, if you're there, then your now is there now, and what's it like there? Well, we won't know that for 1 billion years, but if you're there and you look back at us, you'll see us 1 billion years ago. So, like, for example, someone who was on a star 65 million light years away, looking at the Earth, would watch a big asteroid hit the Yucatan Peninsula. Now, would see Earth back some 65 million years ago. So the issue about what now is there when we say what was happening at the visible edge of the universe back back at the when the microwave background flashed, you say, well, what's happening there now? Well, what's happening there now is our now, right? That's a thing. This notion of there's somehow some absolute clock to say Andromeda 2.1 million light years away takes 2.1 million years for light to reach us. So we see it now. It's incorrect to say we see it as it was 2.1 million years ago. That assumes there's an absolute clock. There isn't. Right. Our now includes what happened there that took 2.1 million years to reach us. Our now goes back in time, back the light cone back in time. And to say, well, what do they see now? Well, they see now our past. They would still see Earth. They would see Earth 2.1 million years ago.
Right.
If your now was there. It's about word lines, and that's a hard problem for people to get in touch with, because our language doesn't really do well for
relativity.
For that.
Yeah. All right. So we also have a question from TP Seeker. How many observatories are in Antarctica?
There actually are several. I mean, I know that the major observatories are at the South Pole Base at Edmund Scott. There is also observatories at Byrd Base. They're at Vostok. There are ones at Dome C, and there's some minor ones. I think there is a minor one at McMurdo. There are also some floating ones. There's temporary ones. Like there's a thing called Alice and a thing called Atlas that floats around. There are observatories that are on balloons, and they float around on air stuff. That is so they're kind of they're up when they float. They float for an extended period of time. And so in the case of something like this, it is a system. There are systems that are temporary that come and go. And of course, there are observatories like IceCube that are neutrino observatories, and there are observatories that do stuff in optical and stuff that goes in ultraviolet and in infrared. There are magnetic observatories.
Right.
There's observatories that are basically sniffers. Right. There's an area of Antarctica that's called the clean air thing, where people don't go, where they try to keep it as pure as they can, and there are instruments there that are sampling the atmosphere without much way of pollution. So there's a bunch of observatories of a wide range of stuff at spots and bases. And if you look on an Antarctic map for bases, you'll find where observatories are. The major observatories in the interior are at the South Pole base, Amundsen Scott, at Vostok, Russia, New Zealand base, and at Dome C, a European base.
Okay. So I think we have one last question, which is from TD Lane, which is, which rocket is the best rocket?
Depends on what you want to do.
Yeah, that's what I figured the answer would be.
It's like saying which car is the best, which vehicle is the best vehicle. Well, if you need to haul stuff across the country and moving, you're going to have a different vehicle than if you want to go for a weekend ride along the coast and enjoy yourself, right?
Yeah.
One might be convertible, one might be a truck, which could do the other one or the other, but are not as equipped for it.
Yeah.
So it also depends on the payload, how much stuff you have to do, how big of stuff you need to have. It depends upon whether you have to worry about stuff getting squished. When you send people up, you have to be gentle about your acceleration. When you send objects up, you can be more, you can have the throttle kick in better. What do you think?
I mean, I agree. It's going to depend. I mean, you've got different rockets that have different characteristics, different payload capacities, different range for where they can get to in terms of like how high into Earth orbit they can get. Yeah. So I mean, I don't think there's an answer to that one that is simply, Atlas V, it's the best rocket. No, it's not. But I think that is basically going to wrap this up. I'm going to do some quick channel news. So we are doing Kent with Bent 29 on Tuesday. Thursday will be an upload. I have no idea what's happening. Actually, no, I know nothing is happening Saturday. Saturday, we're not doing anything Saturday. We're probably having a debate after show on Friday for a debate that's taking place Thursday after my upload on Gutsick Gibbons' channel. Her channel is linked on my channel page as one of the the channels that's associated there. So go check out her channel because there is a debate coming up surrounding, if I remember correctly, it is surrounding genetic entropy. And we're hoping that genetic entropy actually comes up in this debate, because there's been a debate recently about genetic entropy where genetic entropy didn't actually come up at all. So that should be good. Let's see. Also, Vandalia 1998 is having his stream after this. It's going to be talking about the current civil unrest. So if you want to go check that out, he has a number of panel members. I think Tony Reed is going to be there. I think Eric Vierthaler is going to be there. So, so as far as this channel, though, goes, Thursday we're going to have an upload. Friday there's going to be probably an after show. I'm not sure exactly when. We'll have to work that out. Then Sunday, that Sunday is going to be the crazy birthday stream. So basically, almost anytime you stop in for about a 7-hour period, there's going to be something happening on the channel.
Excellent.
Yep. So stay tuned for that. My original plan for what to stream as far as a gameplay thing that I was going to do in the middle is currently looking like apparently that's not going to work. So I have to recalibrate what I'm going to do there. But I think that's it. And what would you like to shill for there, Landon?
Oh, a couple of things. I think one of the things, of course, if people are into listen to some very educated atheists, I would highly recommend you check out Milwaukee Atheists. They do a Sunday show where they're actually reading the Bible, and it's amazing what's in there. They also do a Friday thing. We're looking at some of the Apocrypha stuff. They also do a lot of videos that are out on that. You also should look at some of the things that Ansgar, Dave, and Ennis are doing with their channel. They're doing some fun stuff, and of course, Pimp Monk is a person to check out. He recently had a tragedy. His dog named Diesel for many years died yesterday, so he's a bit in the dumps. but could use some views and some nice words.
Well, I'm sorry to hear that. All right. Well, there you go. There's some stuff to check out if any of that interests you. Which I think some of it should interest somebody. I mean, my goodness, there's a pretty wide range of stuff there between comedy and the atheist Bible study and stuff. I mean, if you don't like some of that, then I don't know. You know what? Even if you're not an atheist, it might be interesting to get someone else's take on a particular holy scripture. So there you go. All right. Well, I think that basically wraps it up. I hope I see all of you here next week. Or sorry, I mean, yeah, I guess next week for Tuesday with Kent with Bent. I don't have the title again, but I will be finalizing that title today or tomorrow and coming out with the thumbnail and posting that. So,
and like I said, if I can join there, that might be an option if that works out. And keep exploring this favorite universe of mine. I hope it's a favorite universe of yours because got some wondrous stuff to check out, and so ask questions.
All right, well, thank you. And that's going to be it. I'm the Dapper Dinosaur, and this has been Landon Kurt Knoll.